Hello DevNoobs and welcome back to another JavaScript Basics series. This time we are dealing with the date object. Because there's not that much content for each individual method and therefore separate videos would be short and boring, I have decided to split this series into 5 parts. Each part will encompass the methods that are logically related and it makes sense to learn about them together, because there is a high chance that you will use them together as well. I will cover 8 pairs of methods that provide us with a specific fraction of a date. And the 3 remaining methods are related to a difference between methods of each pair, but more on that later. Let's start with years. The first pair of methods is getFullYear and getUTCFullYear. Every pair out of the 8 ones we will cover today has a UTC method and non-UTC or local time method, if you will. The only difference between these methods is that the UTC version of the method returns a fraction of date based on coordinated universal time, and the non-UTC method returns the fraction based on your local time zone. For example, I live in a time zone that is 1 hour ahead from UCT in winter and 2 hours ahead in summer. The difference is because we still utilize daylight saving time in summer. My time zone is called Central European Time, or in short CET. The time zone that was decided to be used as coordinated universal time has the local name of GMT, which is an abbreviation of Greenwich Mean Time. So if you hear GMT, it means literally the same thing as UCT and vice versa. But back to our first pair of methods. Both methods return a year fraction of the provided date. If your time zone is GMT, you will always get the same result from both methods. However, I, living in a different time zone, and with me the majority of the world, will sometimes get different results. Great example is New Year's morning. While I might already be in the new year of 2022, although just by a few minutes, there will be people in GMT, or UTC if you want, time zone, who still wait for a midnight countdown. Confusing? No worries, I will show you in the example. Let's have a new date object that represents the morning of the new year, 59 minutes after midnight. Keep in mind that the values I provided are bound to my time zone, that means Central European Time Zone, which is 1 hour ahead of UCT or GMT if you want. When I use the method getFullYear to get the year fraction of the date, I will get 2022. Because that is a year in my time zone given the provided inputs. However, if I use the UTC version of the method, so getUTCFullYear, I will get the year fraction of the date that reflects UTC time zone as its place of origin. Remember, it is still 1 minute till midnight in the UTC time zone, so technically still year 2021. We will have the similar results with the 2 versions of methods for getting month, date, date and hour. The principle is the same, just the values will differ based on which fraction of date object we are extracting. So I will cover all the other methods at once. Methods getMonth and getUTCMonth extract month fraction from the provided date object. The value is not the actual number of the month, but rather its 0-based index. So January is equal to 0, February to 1 and December is equal to 11. We get index 0, which means January for the non-UTC version of the method, and index value 11 for the UTC version of the method. getDate and getUTCDate provide us with the fraction of the date specifying the day of the month. It is always a number between 1 and 31. In our example, we get number 1 for the non-UTC version and 31 for the UTC version of the method. getDay and getUTCDay methods return the day of the week for the specified date object. Result is always a number between 0 and 6, where 0 represents Sunday, number 1 is Monday, and so on, up to 6, which is Saturday. In our example, we get values of 6 representing Saturday for the non-UTC version and 5 representing Friday for the UTC version of the method. The last pair of methods that are affected by time zones is getHours and getUTCHours. They provide us with the hours fraction of the provided date object. The non-UTC version returns 0 and the UTC version returns 23. That is also by lucky accident its allowed range. It is a number between 0 and 23. We still haven't covered 3 remaining pairs of the methods so far, which return minutes, seconds and milliseconds. But the difference is that their UTC and non-UTC versions don't actually provide different results. Since shift in time zones is in whole hours, no matter what the shift is, the minutes, seconds and milliseconds are not really affected. I have a strong feeling that the implementation of the UTC and non-UTC versions of the methods was more because of consistency than of a necessity. But let's cover them anyway. So to keep it consistent as well, let's continue with the specification. getMinutes and getUTCMinutes return the minutes fraction of the given date object. Both methods return the same value of 14 in our example. Allowed values that this method can return is from number 0 to number 59. The same range of valid values applies to methods getSeconds and getUTCSeconds that return a seconds fraction of the given date object. Both methods return the value of 14 in our example. And lastly, the methods getMilliseconds and getUTCMilliseconds return a millisecond fraction of the given date object. Allowed values are from number 0 to number 999. In our example, we get a value of 587. So far, we have covered 16 methods, but we will cover 3 more. They are a bit different to the ones I have already mentioned, but they do relate to them in a very meaningful way. That's why I put them together into this part of the series. Let's make sure I was right to do so together. The method getTime returns the number of milliseconds since the Unix epoch, which is just a fancy name for midnight of 1st January 1970. By midnight, I mean the beginning of the day, not the end, just to be clear. This method technically uses UTC as its default time zone, but effectively it's just a counter counting distance from Unix epoch to current moment in milliseconds. So the time zones don't really matter that much, because once you feed the value of getTime method to the date constructor, you get the date object with your time zone anyway. So don't sweat too much about it and just use it as a plain number when you need it. Another method to cover is the method valueOf, and this method is effectively just an internal implementation of the method getTime. They both return a number which represents the amount of milliseconds elapsed since Unix epoch. You can use its result and feed it back to a dateObject constructor to get the new dateObject instance. The last method to cover is getTimeZoneOffset, which returns the difference in minutes between a date represented using UTC time zone and the same date object represented using the local time zone. If the return value is negative, it means that the local time zone is ahead of the UTC. If the returned value is positive, it means that the local time zone is that many minutes behind UTC. Interesting thing to take into consideration is that one time zone can produce different results based on the time of the year. It is because UTC does not take daylight saving time into consideration, but the local time zones do. So for example, in the summer, the difference between UCT and my local time zone, CET, is 2 hours. My time zone is 120 minutes ahead of UCT. But in the winter it is only 1 hour or 60 minutes ahead because of the daylight saving time. Fun stuff. Fortunately, JavaScript handles this automatically. You just need to be aware of it. As I said, fun stuff. Okay, with that, we have covered all 19 methods and we are done with part 1 of the date object series. I will give you a day or two to put yourselves back together and I will be back with part 2, which will be about methods that like setting stuff into place. As always, thanks for your attention and I will see you soon with another episode.